And that way I can share it to you guys too afterwards, you know, especially people who are related and all that stuff. So yeah, so we're going to go over, was it section 11, so JSON and XML. This is kind of a, what's it called? This is an important part of, like, it's going to be, to be honest, it's not super exciting. I mean, maybe you guys are excited about like data formats in general, but it tends not to be. Basically, this is kind of our precursor to get into APIs and then into web scraping. So let me pull up a little bit. Sorry, I came from another meeting, so I'm kind of not the best prepared right now. So I'm pulling up my stuff. But as I find this, just kind of thumbs up, thumbs down. Who's seen JSON? Like, thumbs up, you're like, oh yes, I know exactly what JSON is. I've done that before. Thumbs up, like, I don't even know what you're talking about. I haven't read the section yet. Sideways, like I think I heard about it. Okay, cool. I like the immediate, like, nope, like, I don't know what that is. That's perfectly fine. So we'll talk about this today. And then same thing for XML. Has anyone heard of XML or? Okay, I saw a thumbs up. So that's good. So see sideways. Anyone else with XML? Thumbs down for no XML. Thumbs up. Okay, thumbs down. Cool. All right, and Rudy. Rudy, I know Rudy. Hey, Rudy. Rudy was my other cohort, so glad to see you again. All right, so I'm just pulling up this guy. Sorry, it's hard for me to talk and also look and read, and apparently, I mean, it's hard for me to read in general, so let's see here. What are we, data engineering? Ah, okay, cool. So let me go ahead and share my screen, and anyone who's been in my groups before will know that I am awful at finding the right screen to share. I believe that's it. Yes, okay, cool. And then all my windows disappear, and I can't find you guys. There you are. I know you guys can't see me struggle with my windows, but it is a little struggle. Okay, so first thing, because normally I would have this with my other cohorts like I classically go to. These notebooks I'm going to show you guys, they're on the web. Specifically, I think it's data engineering. So we're going to talk about JSON XML, and then we'll talk a little bit about recursion. So I'm going to send this to you guys just on the Slack in general to make sure you guys have that. And just know that I'll kind of update this a little bit as you go through. So if you go back to it later on, just know it might be a little different. So notebooks for today.
So all of the curriculum information in this location, I hadn't seen it before.
Oh, this is just like my more personal notebook set. So like a lot of times when I do like the different sessions that we have, I'll use notebooks put together. And so I'll kind of put these together to make it a little bit easier, to be honest, easier for me so I can be able to find this stuff. But then you guys can reference it too, because then when we go over it, you're like, oh, I can go over it myself, play around with the code, you know, change things up, do whatever you want. But yeah, so, okay, cool. So we'll talk about JSON, or JSON and XML first. So let me go ahead and make this a little smaller. Cool. So, so a couple of things, JSON and XML are kind of like two ways we can format data. We'll talk about JSON, and usually that's how it's pronounced. That I've heard it. Sometimes people joke like, oh, it's not JSON, it's JSON. But basically it stands for JavaScript Object Notation. Again, knowing this is not super important, but it kind of gives you a hint of like where this comes from. Is JSON basically comes from JavaScript, which is a programming language, specifically for the web. And so what's kind of cool about JSON is legitimate working JavaScript. So you can basically copy a JSON and put it into a JavaScript, and it will recognize it. It won't give any errors, basically. So what's kind of cool is that because JavaScript is so common on the web, it's a nice interface to go back and forth. In general, JSON is kind of like the new kid on the block, and by new kid on the block, meaning like the past, at least the past 10 years. It's been around for quite a while. But even a lot of data formats that were not classically done on the web, so like, passing it around and stuff like that, they can still be done in JSON format because they're just so familiar, or it's such a useful tool. XML, extensible markup language, is kind of like a little more old school. It definitely is still used today, so don't say like, oh, it's old school, I don't have to ever worry about it. It is used quite a lot. It's very useful, or a lot of companies will use it who have been well established. For example, if you're doing something in finance, you'll probably see XML over JSON. And that's because they just have a strong hold of like, what they've been using. XML also, has anyone seen HTML? Maybe they kind of built like a little website before. Has anyone seen HTML? Okay, I see a couple like nods, a couple hand raises, cool. So XML is kind of like the general HTML. So you'll kind of see it very similar to each other, okay? So that's kind of like an introduction of what JSON is. So let's go ahead and get into this. So my JSON. So this right here is a JSON format, right? And so basically it's kind of describing a few, it's kind of, it's layered in. And so you'll kind of see some similarities. For example, this looks like, if you're in Python, what does this look like to you guys when I see these curly braces?
Dictionary?
Dictionary, right? Yeah, and we'll actually see in Python, these JSON objects will be translated into dictionary. So you can kind of see here's your kind of dictionary, and like here's like, you know, like would be the key. And then you can see here is a little complicated because you're like, wait, there's a dictionary, and then inside here would be a dictionary, and the key would point to another dictionary, which you can do in Python. It's just that that's not what we usually think about, but you can do that. Inside with this guy right here, we have another dictionary, and then this dictionary you can kind of see, and I'm saying dictionary, it's not really, but you can kind of see the similar format. Is we have our key, and this would be our value right here. So it'd be like, oh, if we had a key ID, we get file right here, value, file, and then we have pop-up, and we have another new dictionary. So this like dictionary's value would be another dictionary. Again, I'm using Python terms. I just want to make that clear. And then we can see here that menu item in that dictionary would actually point to, what does this look like with this square bracket?
List.
A list, right? Yeah. So we actually have a list right going on here. Like that's what it would look like. And you can see here in this list, we would actually have a list of dictionaries, which again, you can see kind of like this layered going through. And this is kind of like JSON has a very like loose structure in this way. So it turns out we can have certain items in there, and it's kind of like all the items that you can really have basically are objects. And what an object for a JSON object, you know, notation is what we call as dictionaries. That is a JavaScript object. It's the same, it's equivalent to each other. We have arrays, and has anyone got to guess what an array would be similar to in Python?
Like a NumPy array, I'm guessing now.
Yeah, no, NumPy array, that's good. So NumPy array. And what kind of Python object, so not NumPy, would be most similar to like an array, a NumPy array?
List.
A list, good, awesome, right? So that's really when you say arrays, you can think of like a list in Python. They're not quite the same thing, but they're pretty close. And then in JavaScript, arrays are basically like Python list. And then we have our strings. We know what a string is. We know what numbers are. A Boolean true, false. Note that true and false in JavaScript, in Python, we have capital true, capital false. In JavaScript, we have lowercase true and false. So there's a slight difference in there. So it's not 100% like direct Python. Like I couldn't always copy this and say that's direct Python in there. And then we have a null value. And then what would be the equivalent for null in Python?
None.
None, good, right? Yeah. So like usually you'll hear null for most programming languages. That's kind of the classic. Basically it's representing there's nothing here. So in Python, we say it as none. So you'll see this a lot like in Python, in like pandas, for example, saying about like none objects versus null, okay? So cool, so that's kind of like what JavaScript looks like. And so we're actually using this in Python. What's nice is that it's built into Python already. We can just simply import this JSON package, and we can open up, let's say, a file. So I have a sample file back here, sample.json. We'll take a look at that in a second. And then we can basically say, okay, open this file. That's what this represents. We're saving this file in here. And then JSON has this, this package has this function called load. And basically this will load the file into something that Python can actually understand. So let's go ahead and take a look at what this sample.json looks like. So you can see here, I just copied some JSON. I think this is actually directly from the curriculum. So you can see here, like you got that little curly brace, kind of like a dictionary. Also in JavaScript, it's an object. We can see our first key here would be meta. And so if I close this, for example, you can see, okay, it's a list, or it's a, not a list, it's a dictionary. So we have meta, and there's some stuff right here. Oops. Sorry, I made it a little small. There we go. And then you can see the next one would be data, which goes to a list of things. Okay, and then that list, there's like a list of lists that looks like. So there's a whole bunch of information in here. And so you can kind of navigate all the way through. Sorry, turn off my notifications. There we go. So we can kind of see like how this would be structured through. So if we actually try to load this file in here, and we see what data looks like, and you can see here, this now is a Python, like legitimate Python variable now. We have information in here. And you can see here, there's the meta. And then if I were to go further down, we would see more like, you know, the data and stuff like that that we saw from right here right? So just to kind of show you that this is in fact, oh, this is supposed to be code. There we go. So if I run this now, you can actually see that this data will be, does anyone got to guess what type this variable will be?
Dictionary?
A dictionary. Good, right? So we can actually get like, and just like before, like I said, this is just like a dictionary, or this is like just like Python dictionary. We can now say, what's the first key in there? Well, we can do meta, for example, and we can see that's the first key, and you can see that's the dictionary points to another dictionary. If I wanted to see all the keys of that dictionary, since we know this, we can say get keys, right? Or not get keys, sorry. I'm thinking the wrong language. Keys, right? So we can see here's all the different keys for that dictionary. If I wanted to get the keys of, let's say, of meta, I can see here's all the different keys, and there's only one key, it's just view. But you can see kind of navigating through and going through all that stuff. We saw that one of the keys was data. We can actually see what type this is, and we can see that this right here is going to be a list, right? Which kind of made sense what we saw back here. This data key points to a list, right? So we can start seeing like, okay, like cool, we can actually print that out and explore it. And the point is that I'm trying to show is that you don't really know what the structure is going to be of this JSON thing until you basically explore it yourself. And that's kind of the JSON and XML ultimately, its strength and also probably like its biggest frustration. You never know exactly what it's going to look like, which is good that it means it's very versatile. You can use it for whatever you want, but it means that you don't know what it's going to look like until you get into it. And we'll see how that relates to recursion. Okay, any questions now how we're loading this up and how it's translating into Python now? No, thumbs up, sound pretty good. Oh yeah, go ahead.
So every time that you have a .json file, when you import it to Python, it's going to look like a dictionary?
Not necessarily. So for example, if we had, let's see if I can change this up. Well, this will mess it up. But like if I were to change this, for example, like to a list, it would import it as a list. And so this is kind of how it kind of quickly reads things. For the most part, though, you probably will get a JSON. The first thing you're going to have is a dictionary. And that's because dictionaries for Python are equivalent to objects in JavaScript. And note that we call it JavaScript object notation. Most of the time, we're representing an object when we're passing in these files. So usually you'll have a dictionary, but not necessarily so. So just kind of be aware of that.
Okay, thank you.
No problem. Good question, though. Cool. All right, so cool. We got this imported in there. So first thing I'm gonna do, we love pandas. We're data scientists. We love kind of playing around with that. So we want to make a data frame, right? So we can see here, like I mentioned, we can do data.keys to see what's available. And this is where I'm actually gonna comment out one of these. So I'm actually gonna do this df.meta, okay? So this is basically gonna be our data frame that's gonna be the meta stuff. So as we saw kind of before right here, it's gonna be this dictionary. I don't know why I keep doing that. But basically it's gonna be this dictionary, try to put it into a data frame. And so if we actually run this right here, you can see I'm getting data frame, or sorry, the data and giving meta. So if I do df, let's actually just make a new one, df meta, and this is data frame now, I can now go ahead and print that out. And you can see here, we can get the first few parts. And you can see here, it's not formatted probably like the way we'd like it to. So you can see here, for example, this first part view is not really giving us like anything interesting in that sense. In fact, if I do like, let's say head of like 15, you can see that it's kind of a funky looking like list and stuff going on here. And that's because the JSON object, like we can import into data frame the best we can, but it might not work the way we would like it to. And this is where we kind of have to massage the data. Like all of it's there. It's just like we have to figure out what the parts are relevant and how we're going to retrieve this. And this is actually what a big part of like APIs, as you guys will go into the next section, basically getting that API information, getting the data from an API and massaging it into something that's useful, you know, for our, you know, data processing, like, you know, a pandas data frame. Okay. So similarly though, I can go ahead and do this df.data, and let's go ahead and write this guy. So you can see now I have my data frame for data, and let's just do a dot head. And we'll see it's a little different here. So this one's a little closer to what we would expect in a data frame, and that's because our data, here we go, this data was a list. So it was easier for us to import that into a list of stuff. But you can still see there's some parts in here like this are some kind of funkiness. And again, this is where like it all depends exactly what the data is formatted as, and you have to massage it and understand the context of what you're doing. You can't just simply say, oh, import a data frame, because Java's or JSON files can be differently formatted. Like there's no guarantee exactly how it's formatted. So essentially what you're gonna have to do is always know what things are relevant. But it's nice that you can directly work with it in Python. Does that make sense to everyone?
In the second data frame that you created for data, you used from underscore dictionary, but it's a list.
You're right. So this is kind of a weird thing. I could have possibly, actually, let's see if I do a data like here. I think this won't work, but let's see.
Am I thinking right?
Yeah. So yeah. So basically what's nice is that it's kind of confusing, even though this from dict part, if you just pass a list, it just treats it like, oh, it's a dictionary, but with the keys are the numbers. So that's why, for example, you see up here is that those keys are just numbers. That makes sense? So it's kind of a weird quirk. It's like technically you're right. Like it shouldn't technically work, but with the if, for example, I pull up the documentation, you can see here from dict, all it needs is data, which is like a dict of array like or dictionaries. So basically, if it's an array like, which means like a list, we can just go ahead and import it through, even though technically it seems like it should just use a dictionary. So, and this is just documentation stuff. That's not something you would necessarily know unless you read this up or have experience with it. But good catch. Okay. Does that clear things up?
Yes, thank you.
No problem. All right. Any other questions? All right. Sound good? Sound good how we can read it in and then read into our data frame. Basically play around with it. You know, we could do whatever we want. Cool. So now it's like, okay, cool. What if we want to do the opposite? So a lot of times in APIs, you don't just get data from something. You might also want to send information to somewhere else. And so a lot of times they don't know how to read Python. They're just like, I'm expecting a JSON file. And so what you want to do is be able to export your like data frame, for example, and export that into a JSON format. So you can basically send it into the format that essentially what we'll talk about next time, well, I guess probably we'll talk about next time, is you're talking to a server. You're basically giving information out to it. So you want it to be in the right format. So this is where we can output it to JSON. So this is kind of like doing the reverse. So here, for example, you can see I actually created, I think this is literally what I had copied up here at the very beginning. So you can see there's a little format. And I'm basically just creating like a legitimate, and I'll just put this out just to kind of show you guys, is I'm making just a legitimate like dictionary right here. And this is completely in Python. There's nothing, you know, funky going on in here. So basically I format this in the right way. And it's like, okay, cool. Like now it is equivalent to JSON. I can basically export it out to an actual file, and I can write it into this output.json. And I realize I actually have, oh no, I don't have it. So you can see here, I only have sample.json and sample.xml we haven't seen. So you'll see when I do this with open, which is basically saying, open up this file, write to it, and you're gonna write to it as f. This is kind of like a Python idiom that makes it easy for us to write to files. There's a couple ways you could do this, but this is kind of the most common way. And basically say, okay, we're gonna write this to a file, and basically this JSON.dump is gonna dump all the data in a JSON format based on here to the file f, which is going to be output.json. So what we should see is that we'll write this out and we'll see a file that will basically look like the JSON file, okay, called output.json. So if I go ahead and run this, you can see it executed fine. And I can now see that there is an output.json. And I open this up and we should see, here's the menu, ID. No, it's like super clean and everything like that, but it's all there. So you can see here now I have all the information that we had before. One kind of fun thing I should notice, or you should notice, for example, I said about like booleans. So this is legitimate in Python, right? Capital true. And so when I dump this out, this doesn't make any weird things because you'll see that the true is actually lowercase. And that's because it's representing a Boolean, it's not a string. And so in JavaScript notation, trues and falses are lowercase, even though in Python they're capital. But JSON.dumps realizes, hey, that's not just like a word true, that's a specific Boolean value true. So actually it wrote this part here. Similar if I put in, for example, none, which is classic Python, right? If I export this out here, you can actually see that we have a null value, right? So basically JSON's kind of like the interpreter. It's interpreting back and forth for us saying, hey, okay, JSON.dumps basically says, here's a Python object, convert this into JSON. And then the opposite with JSON.loads is basically taking in a JSON file and basically passing it into a Python equivalent. Okay, so cool. Any questions on any of those two parts? Seem pretty good?
When you did the dump, I'm sorry.
No, go ahead.
You dumped the data and then comma F. What's comma F?
Yeah, so that F right there it's kind of weird. This is the hard part. Like, honestly, this is not super clear. Is that this idiom right here basically is opening up a file called output.json. And so this as F basically is saying this F is representing the file output.json. So this is kind of like, to be quite honest, this is not super like I've thought about like ways to explain this. I don't think there's a good way to explain it other than like idiomatically. But basically what's happening here is with part is saying temporarily open up this file for writing access. So that way I only write to it. That way I can make sure I don't accidentally, like if I only just want to read it, for example, I could put an R here and make sure I don't accidentally write to it. So this is kind of saying what access you should have to be safe. So I have this W to say it's writing, and I say, okay, this file right here, temporarily open up this file for writing access, call it F. So I could have named this file, I could have named it, flippity flop, it doesn't really matter. And then say,
I just
okay,
wanted to make sure it wasn't a keyword. So that that could be any variable name there.
That's right. Yeah.
Okay, got it.
And this is where, like, if you have the code too, you can always do like a shift tab. You guys know the trick shift tab? Oh, this will be fun. So what if you do on your keyboard, if you have your cursor right at the end of a function that's already defined, if you do shift tab, this little window pops up on Jupyter Notebook that will give you a little bit of information. It usually isn't a huge amount of information, but it might give you enough information to figure out what's going on. In this case, it probably is not super helpful, like what exactly is going on here. But if you wanted this part, it's like, okay, like there's more information here. You can click this up arrow, and this will expand the whole Word doc, the doc string basically of what's going on, and you can read this. I personally don't do this unless I really want to quickly say, hey, oh, what is this again? Like I'm familiar with it. If I really don't understand it, what I do is I literally just go to the documentation website. So I go literally search json.dumps and like look it up. And so for example, this is the documentation. So if I wanted to know what this is, I go like, okay, I go Python JSON dumps. See, Google already knew. So like I can take that up there, and it's like, okay, like let me look for it. And I might look for the documentation. It's like, okay, like this is what it is. Well, this looks like it's coming up. So I might check, it's like, well, let me see what this is, and I'll kind of read through it and get a better idea. In this case, this might not be the best documentation, but I search for dumps and say, okay, well, there's coming up over here. And I might kind of explore here and try to figure out what's going on here. This at least kind of helps you a little bit get a little more context.
Okay, thank you.
No problem. Cool. Yeah, so a handy trick right there is that shift tab, like I said. And it's useful for any function as long as it's a doc string. Even functions that you define. So if you define a function and you define a doc string, you can do shift tab. That's why documenting your code is super useful. Not just for other people, but for yourself. Cool. All right, so thumbs up on loading JSON, outputting JSON. Basically, it's Python in disguise. Like it's basically a nice format going on here. Okay, cool. So this leads us into XML. So XML, I'm going to be frank with you guys, is a bit of a beast. It's kind of older school, so it technically works, but all the cool kids now use JSON, so it's like really well developed and everything. So just kind of know that you'll see this kind of like ugliness because it's just been around for a while and just hasn't, like, to be honest, people don't care about it as much. So like most people will use JSON and they'll use XML only because they have to, or because that's all they know. So just kind of know. So XML has kind of that same structure of like whatever you want kind of thing. You can have like nested parts over and over. This one's a very simple example of a note. So you can see here like, okay, this is saying this is a note. This is kind of like their tag, and say this tag is a note. It's like, okay, that means everything within here and ends right here. So if you've seen HTML, it's very similar. But basically say, okay, here's my tag, and all of the stuff before I hit this end tag, this will be note. Notice that I tabbed it over this isn't necessarily needed to do XML or even JSON. It's just easier for us to read. So if I put this all in one line, it's ugly, but it would still be valid. Okay, but basically it says, okay, this is a note, and say, all right, now we have our to part. So like this note is to Yona, from Danny, the heading, don't forget, and then body is we're going to the party tomorrow. So that's how you kind of separate those different, tags within there and kind of have that layered part. And I could have like layer, for example, that body, I might have a paragraph, or I might say greeting, or like, it could be whatever I really want in there. And notice that like, is this how you always define a note? No, it can be whatever you want. XML essentially is very customizable. You can define it however you want to define it. If you find it that, what's it called? If you find that you want to use a different phrasing for this, you could do that. And this is where like you'll see much more technical jargon. But this is kind of like, you can kind of get the idea of what this is trying to express. Okay. So any questions on this XML part? Okay. Pretty straightforward. It's formatted in the same way that JSON's formatted, in the sense that like there's layers, except that we, instead of defining it like predefined, like, oh, it's a curly brace versus a square brace versus quotes, it's just saying, oh, this is just going to be a tag that represents whatever this is. And these things could be numbers, they could be like words, they can be whatever you want. Okay, if this works. Sorry. Oh, that's cool. I didn't know I could do that. So yeah, you can see here the format right here is highlighting the tags, and then inside those tags are the actual values. Okay, cool.
So the tag can be any name. I can name the tag whatever I want, or
yeah.
Okay.
You can like flippity.
Yeah. Okay. As long as you end it. Okay.
Yeah, and as long as it ends at the end, you might have like, you could give issues if you don't close it, for example. So kind of be aware of that. Usually you would use terms that are basically, if you're using XML and JSON to communicate with a system, and usually that other side, whoever you're sending it to, has to know what to expect from it. So basically, if I replace all these like with meaningless words, you would have no clue what these things are supposed to represent. So yeah, cool.
Thanks.
No problem. Yeah. So just know you can customize it. All right. So parsing with Python. So again, there's documentation. It is built into Python. Here's some more parts. And I will tell you, if you thought the JSON seems like, oh, that seems kind of confusing, you get kind of warning. XML is not the prettiest thing, in my opinion. Maybe some people find it pretty, but I don't really. So you can see here is that instead of importing like JSON, we do import xml.etree.elementtree, and I'm calling it as et, so I don't have to write this whole thing out every single time. So basically it's this package called XML, and inside XML there's some extra little parts in here, in this case an element tree. And then to get this tree, so we'll kind of see like it's going to branch out from like the start, kind of like how JSON, in JSON would be like the beginning, and then it'd be like data and meta that we saw before, and then from data and meta it would spread out even further. Because XML doesn't have a defined like, oh, this is a list, this is an array, this is, a string. It's just going to say, what is the tag, and within that tag, if there's nested branches. So it's much easier to describe this as a tree. Okay, and usually the tree is kind of like facing downward when you see this in programming kind of style versus facing up. But no, it's the same kind of idea. Okay, and so the root basically is going to be the very first element in here. So we're going to read this, we're going to parse this file, sample.xml, which I have in here. And this is what it looks like. Oh, that's right. I forgot this happens. So I'm trying to remember the best way to do this. This happened to me before too. Okay, this is kind of similar. The problem is that because XML looks like HTML, Jupyter Notebook is saying, oh, look, it is XML, and it's really not. I actually wonder if I can edit. Okay, good. That's better. So you can see here is that when I click on it, it automatically tries to view it, which is super confusing. But you can see here the tags, there's a response. It's a little messy because it's all in one row. But you see row, and there's a row in here. So what I kind of showed you is Chrome basically has a built-in, and most browsers have this, is that this is the stuff right here. So I have response, a row, and then inside that row, so you can see the one element within response, there's only row. And then within that row, there are multiple row ID or rows. And then this part right here, this underscore ID, you can see here are kind of like attributes. So it's kind of like part of the tag. It's kind of like information about what you're going to see in. So it's saying, oh, this row is ID equals 1. UUID is basically some identifier for this part, position equals 1, address right here. And then inside this row, you can see that there's subtag or like it's children. It's little tags within here. So candid name, office borough, and can class. So this is about elections by chance, if you didn't get that feel for it. So you can kind of see where this structure, and you can see here is that each sub, so you can see row and row are at that same level. We'll call those siblings, for example, because they're kind of like at the same level. And then, so underneath here are its children. And you can see that children don't necessarily match up with the children right here. So this is very, again, versatile. It's very flexible, but you pay for that by basically saying you don't know exactly what's going to be in there. Okay. Yeah, so hopefully you can see this structure here. Any questions about these attributes? I kind of didn't mention about this beforehand, but does everyone understand like what's going on with these attributes within here? And this is where, like, if you're HTML, like, you might be familiar with a little more of what this looks like. Okay, so one thing I want to mention about the attributes is that it's kind of describing the tag itself. Technically, you can put, like, any attribute you put in there, you could technically put as, like, a child within it. So you can basically just have row and just have, like, attributes underneath. But usually the attributes are important in the sense that they're tying directly to the tag itself. So you can see here is that the tag itself is talking about, this is ID2, this is the UID, this is the position 2, and this is the address. And then inside it is talking about this information underneath. So kind of know that's kind of the convention. That convention might not be followed depending on what business or whatever, you know, data you're getting a hold of. Everyone, because it's user inputted, they can decide however they want to format their XML. But generally the attributes in there are going to represent around the tag. Okay.
So for row ID, those are attributes about the row ID.
Yeah.
So how you would read that?
Yeah. So like you can say like there's this tag row and it has attributes underscore ID, underscore UUID, attribute underscore position. And the values for each of those attributes, for example, underscore ID is like, oh, that's a 2, like saying the ID is 2. Underscore UUID, that's this value, this long string of things. It's position 2. This is where like also is kind of a hint that this is kind of metadata, is that underscore part usually is kind of like extra information that you kind of don't need to care about. Usually if you see that underscore and then a variable name, that's usually like a lot of times used in Python to say, don't worry about this variable, like kind of deal. It's kind of like inner working metadata. Okay. Does that clear things up a little bit?
Yes, thank you.
No problem. Okay. So let's go back to, I've got so many tabs now open. All right. So we'll go ahead and run this, and we're actually going to read in that file that I kind of showed. And so we'll get our whole tree, and the whole tree basically is all of the stuff like we have in here. And the root is basically the very first part, which I think the very first part was row. There's multiple rows, but we have the very first row. And then we're basically going to say, all right, first children of this root. So this is a list comprehension going on here. And basically it's going to look at each node for node inside of the root. So what this looks like, kind of going back to here, kind of make this a little smaller, is that this right here, I'm sorry, I misspoke. Response is the actual root. And so the first children would just be row. There's only one child in here. So let's go ahead and see that. And I'm actually going to split this so we don't have to worry about this. And let's go ahead and look at what first children is. So you can see here, it's element, oh, you can't see what this let's see, print. I'm getting the first child because it's a list of children. And you can see here, it's element row. So that's because our first part was response. Our first child, there's only one child, is row. Okay. So our next part is our grandchildren. So we're starting again at the root. And what we're going to do, we're going to say, okay, we're going to start with for node and root. So we know that the first node and root, and there's only one, is going to be this element row. And then it's going to say, okay, for that like child, right? It's going to say that grandchild for grandchild in node. So that node is that child. So basically it's a list comprehension with a list comprehension. But the way you can read this is say, okay, you first look at the node within root. And so for each one of those nodes, which is only one, so be row, go ahead and drop and say, okay, for all of those grandchildren within that node. So what this is going to look at is going to first say, okay, here's my root, here's my node, there's only going to be one. And then for each one of those nodes, look at all the grandchildren, which are going to be these guys. Okay. So we'll see how many grandchildren there are. Oops. So let's go ahead and do this, and we'll go ahead and do grandchildren. Oops. You can see here, each one of those grandchildren are a different row. So I know it looks kind of confusing because they're both named row, but you'll see that this is actually a different row. And we can see, for example, like, well, how many grandchildren is that? And we can see 285. And so it's kind of nice is that because this data is nicely formatted, we can actually look at that. There's 285 elements in here. So basically it's counting each of one of these things. Okay. Note I also could have, I think I took this from the curriculum just to kind of show this part. I also could have done, instead of, like we had first children already, I could have done grandchild for, what's it, first children. So I could have done this way, and this would have been the same thing. Oh, well, maybe not. But basically, you can kind of replace this part depending on how we have this in here. Anyway. Okay, cool. Does that make sense how we're kind of navigating through it, kind of going deeper and deeper? Okay, so now we say, okay, we can kind of navigate through here. How do we actually check this out? So this is where, for example, I talked about having the tag. So the first child was that row, and then the different parts of the attributes. So in the very first one, if I scroll all the way to the top, we can see our first guy, our first child is row with no attributes. So we shouldn't see anything in here. So you can see the tag was named row, but there were no attributes because there was nothing in this part right here. Okay. And then I can do something similar is with the grandchildren. So I'm going to go ahead and print out all the grandchildren, right? So this is kind of similar to what this is. I'm going to say, okay, for the very first grandchild, what is the tag? And then what are the attributes for that first grandchild? So that's going to look at this guy right here. So our tag should be, what should our tag be for this grandchild?
ID?
It won't be ID, it'll actually be row here. So that's the actual tag.
Oh.
But no problem. And then, so our attributes though, these are different attributes. It'll be a list of underscore ID, underscore UUID, and so on. So let's go ahead and run this out and see what this looks like. So we'll see 285. We can see the first tag is row, and we can see here is that our attributes, notice the dictionary, it's like, okay, this is the actual attribute underscore ID with a value of 1, underscore UUID with a value of this long string, underscore position with value of 1, and so on. So you can kind of see here, it's like, now that's how we can navigate and grab all the relevant information. Does that make sense to everyone? Thumbs up if it sounds good, thumbs down not.
So
Okay.
what is that, the value besides the attribute? Where do you see this 1 and this underscore UUID and the values for each attribute?
Mm-hmm. You're saying like within the actual XML?
Uh-huh.
Mm-hmm. So yeah, so if you look at, there's 1 and then there's, let's say, position 1, we can see here is that,
Oh.
can you guys see that okay? I know it's kind of small.
Okay.
Yeah, so that's where like it's, this row is that tag right there. So let me go ahead and, let me see if I can go ahead and copy this real quick. And then here. So this is the row, so this is the actual tag. And then everything underneath that underscore ID is that first attribute is equal to 1, underscore UID. And then you can see there's this value all the way through and so forth. Okay, does that make sense? Cool. And you can tell this is the tag as well because it's the first one on here. So the tag is always first. And then also note that on the row, we can see that there's going to be an ending part. So you can see that little bracket, like that triangle bracket, backslash or forward slash row, and then the bracket again. So that signifies, I guess, ending the tag in here. Okay, cool. So yeah, that's kind of like how we're able to like take this part and actually navigate through it. And then we can see here, this is actually from the curriculum as well. If we wanted to go through the whole tree, for example, again, this is a little more complicated. We can do like this root.iter, and this .iter basically is a function that's going to create something called an iterator. And this is kind of like when you guys ever do like range. So we know range, right? So when we do like range of like 3, if we try to like print this out, you'll see that it's just like this value. It's not like a list of things. I could, for example, do like list, oops, and cast it over to a list, and that'll be 0, 1, 2, right? But you'll notice it's like, oh, that's not really what this represents. In fact, if I do type, I think this will show there, if I have this right. To the type range. But note that this is an iterator in that same sense. So what you're basically doing, this iter is like, oh, just give me the next one. So we just give me the next one, give me the next one. So basically what this is going to say is like, okay, from root, okay, give me the next element on there, okay? And it basically, this count is going to be going through here. It's going to increase by 1, and it's going to cut off when the count is, if the count is less than the cutoff, it'll print it out. And if it's more than that, it'll just stop. Okay, or I guess it will skip over, it won't print it out. So you can see here is that basically it's going to go through each part, and it's going to iterate through that, what's it called, through that tree. And the way you can kind of think about this, instead of going like, it's like the way I'm counting this, I'll kind of go like this. It's going like, okay, here's 1, here's 2, here's 3, 4, 5, 6, 7, and then 8, 9, 10. So you can kind of see it ends at, well, in this case, it ends at election because there's multiple rows. But you can see it's going to iterate through basically as deep as it can all the way through. And so if I put it, for example, I put it for 15, it would go a bit further. It would go into that election, candid, can name, office, and so on, which is basically these parts. Okay. Does that make sense to people?
Can you go back and let me see that XML again?
Yeah. So we can see here, this is our root, our response, that first child row, that grandchild in there is row with all these different attributes. And then within there is candid, can name, office borough, can class. And that's what that iter is doing. It's basically just going to go all the way through the list as deep as it can all the way out. So versus like if we talked about just grandchild, if we just did grandchildren, we could just say row, 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 all the way through and never have to look inside it. But iter will actually go all the way into it.
Got it. And so it'll come back with that 285 because I think that was the link.
It won't, it'll actually go deeper than that. So if I actually, we can try this out real quick. If we do like 285, we'll see that it won't actually go all the way to the bottom because it's not just counting, this is going 1, 2, 3, and then skipping over. It's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, I'm done counting it. But like that's how it's kind of counting.
I see. Okay.
Sorry. My dog's kind of a little puppy. Hi, stop. Okay. All right, you said hello. Go away. All right. So anyway, that's kind of how the iter kind of goes through and everything like that. Okay. Any other questions? No? All right. Sorry. She's kind of hyper right now. All right. Hi, stop it. Sorry. I can probably keep talking. If he gets too distracted, I'll kind of push it up. I know. Oh, thank you. So anyway, that is how you would go through XML. So similarly, like, you know, once we have the XML, we actually want to be able to do something with it, like a data frame, right? So again, we're data scientists. We actually want to use pandas and go through everything like that. Okay. So you can see here, and this is directly from the curriculum, but I kind of wanted to show a little bit. I'm not going to kind of walk through it. I think the curriculum does a pretty good job. But basically, you can kind of see here, we can try to create basically this list. We're going to iterate through this root. We're going to go through each part of it. This enumerate part is basically just a special thing where it's going to do that iter. So it's going to give me the first one, the second one, the third one. But it's also going to pull the number that's coming in there. So this enumerate is going to pull out, like if I did, let's see if I can do this real quick. Well, okay, we'll do it later. But like basically, this is going to be like a list of 1 comma and element. Okay, so that's going to allow us to do stuff, and basically we're going to build up this list, and then once we have this big old list of things that we actually care about, then we can go ahead and put it into a data frame like this. And you can see here, like I said, it doesn't make it really easy to like navigate through. XML is not really modern, so there's not as many modern people like using it kind of thing. So you'll see kind of like that ugliness kind of pop out when things aren't used by many people. Okay. So if I run this now, you can kind of see we have a little nicer, you know, format. For example, we can see here, okay, here's the ID, we got the UID, the position, so these are different attributes. We also could have possibly, instead of just doing element.attributes, we could have also like put in other stuff as well in there. So for example, if there was something like if we knew a candidate name was going to show up every single time, we could put candidate name as part of this part in here. But again, this all depends on structure, because we saw in the XML, it's not structured the same way every single time going through. Okay.
Okay, real quick. So on top, the code that you have on top, you have iterate, dot iterate, and no arguments in that function. So it's giving you everything. In this one, you're looking just at the attributes for row, and you're iterating through that.
Yeah, so I'm looking for just terminology tag. I'm looking at just the row tags. So
just the row tags. Okay, got it.
No, good catch. So yeah, you can see here that we could pass this in here so we could have different parts. So this is really useful, for example, if you know the structure of the XML, like I only care about this tag, and you can say, I'm gonna iterate on this tag. Okay. Cool. Any other questions on this? Okay. Sound good? Thumbs up, thumbs in, sideways. And it's okay to be sideways too. Like don't feel bad, like I don't really know. Because this is like, honestly, it's a little messy, right? It's not super clear. But hopefully you can kind of get some practice on it too. All right. So kind of comparing the two formats, there's this great website called json.org, which is just gonna be amazing if you're like, let me take this guy, which was our original guy right here. This is an example I got from this website. This is the JSON format. This right here would be the XML equivalent. So the JSON, this json.org, they have a bunch of examples that kind of show you, what the JSON equivalent would be, and then what the XML is, would look like. So you can see here, for example, here's our example with menu, and here's the equivalent for XML. And note that it's the same data, it's just formatted in a different way. And you can see here how the XML tags have to basically define the tags as these elements in here, versus JSON basically just using a dictionary, equivalent to a dictionary. Cool. So, any last questions about this topic? Sound good? Cool. All right. So last thing I'm going to talk about, I know we only have about 10 more minutes going through. And this is where if we were computer scientists, we would spend a lot more time on this specific topic of recursion. For thumbs up for anyone who's ever seen recursion or heard the word recursion before. Okay, a couple. It's a very computer science-y subject. So just know this notebook is on there. This is much more of like, I'm not going to go through the full code because honestly, in reality, you probably don't need to go really deep into this recursive, like what is recursion. But it's really useful. Like if you think of a for loop as going through a very nice structure, recursion allows us to say, I don't know what the structure is, but just keep digging until you hit something. That's essentially what recursion is going to allow us to do. So again, like what is recursion? A little joke here, what is recursion? So recursion basically kind of repeats itself over and over. So it's functions that are calling themselves. It's an alternative to looping. It's a little more advanced. It's not typically done as much unless you absolutely have to. Usually things are optimized in for loops, but it's really good for unknown structures. So if you don't know what the structure of your, thing that you're looking at, like a JSON or XML, you can use recursion to make sure that you just kind of keep digging into it until you hit something. Versus a for loop, you kind of innately have to know what the structure looks like beforehand. Okay. So here's a couple examples. I put like I'll put, for example, like a sum versus a loop, or a sum for a for loop and a sum for a recursive function. So doing the sum here, I'm basically just defining a sum loop. So this is going to be my for loop. So I'm going to get a list, and I'm just going to say, okay, total starts equal to 0. Start off there. And then for each element in my list, so it's going to be a list of 1 to 100, or I guess 1 to 99. But basically, I'm going to go say for each element in that, I'm just going to take the total and plus equals into element. Okay, so hopefully like a pretty basic for loop, right? So essentially we're just saying 1 plus 2 plus 3 plus 4 plus 5 going on and on and on, right? And that's our definition of that function. And so if I run this right here, and note right here, you'll see at the very bottom is executed in M4 milliseconds, or sorry, for MS, so 4 milliseconds. Note that there's a difference in the timing depending on what you're doing. So you'll notice that recursion tends to be slower for most things because basically recursion doesn't know what the structure is. So it has to kind of assume things are happening. And so things tend to be optimized for loops. So just kind of know that's a little subtlety. But you can see here, I basically executed 13 milliseconds, 4,950. Okay, not too bad. If I do a recursive function, this would be kind of like a way to approach it. So here I'm doing the sum recursion. I'm taking that same list. But in this case, I have to think about things like when do I stop digging? So what this is going to do is basically kind of a divide and conquer. So the way you can think about this is like, well, if I have a list of size 1, if there's one element in that list, the sum is just that one element. If I have an empty list, right, if my list is completely empty, what would that sum be? What would you guys define that?
0.
0, good, right? There's nothing in the list, so the sum should be 0. So that's essentially what I'm doing here. Is like if my length of my list, if it's a list of size 0, basically say, oh, the sum is 0. And then what we can do, say, well, okay, let me just say whatever the very first element in this in there. So if I had like a list of 2 different things, I can say get the first number, well, that's a number of like 3, and then 3 plus the rest of the sum of the list. And that's essentially what I'm doing here. I'm saying, okay, get the first element in there, whatever that number is in there, plus whatever is left over. So basically 1 onward. So basically ignore the first element and go off to the side.
Okay, say that again.
Yeah. So basically we get, this part's pretty simple. It's like, if it's an empty list, we get 0, right?
Got that.
Okay. And so this part we say, okay, if it's not empty, so there's something in that list. Basically what I'm going to say, all right, so if I have like a list of like just like the number 3, right? Get that number 3 with this guy, okay? And add it to the sum. So this is the actual function right here. Say, okay, whatever the sum is for the rest of the list, whatever the rest of the list is, just take it up and then give it back to me. So in a lot of ways, we're kind of being like really dumb. We're like, I don't know how to calculate the sum of the list. Like whatever the sum of that list over there is, tell me what that is, and just add it to this one single number. Okay. So in this case, if we had just the list of 3, it would basically pull out that number 3 and say, okay, 3 plus whatever the list of everything else, which is just an empty list, which we know will actually be 0. And so this will give us back 0, and it'll be 3 plus 0. If the list is, and this is where I'm going to write some stuff down, so it's going to be hard for me to verbally say it out loud. So if I have a list of, let's say, okay, 3, and let's say the next part is like 5, what this function is going to do is like, okay, is this list empty? No, it's not empty. Do this guy. So the first thing it's going to do is like, okay, it's going to do 3 plus, and I'll just call it like f, like the function. So like some recursion of everything left over, which is just going to be a list of 5, right? And so it doesn't know, just like whatever this ends up being, tell me what that is. So essentially what happens is that, okay, this function figures it out and says, okay, is this list empty? No, it's not empty. All right, then do this guy right here. It's going to be 5 plus whatever the sum of left over, which is just an empty list. So there's nothing left over, so it's just an empty list. And it says, okay, I don't know what this sum is, but you know, function figure it out. And then it goes, okay, cool. And so it drops into here and says, all right, is this an empty list? Yes, it's an empty list. So it's like, okay, since it's an empty list, we're just going to give it to 0. And you're like, cool. And that's when everything populates back up. So I'm going to use a different color just to kind of emphasize this. So let me just use like, that's a bad color. Let me try pink. So you guys aren't colorblind or anything. But anyway, I have 0 going on here. And so basically this guy gets replaced. And so now it's just going to be 5 plus 0, right? Because that's that part in there, which is just simply 5. So I'll just cross this out. This is going to be the number 5. And this gets passed up all the way through. So it's going to go all the way up here. And it says, okay, this function then is going to be 3 plus 5, which is then just going to be 8. And so the function will just turn the sum of 8. So you can see here is like, I don't know about you guys, but that feels very complicated. Like that does not seem super like intuitive. And I don't think it is. I think most people don't think in recursive manners. And this is why recursion can take a lot of work. It also can be slower too, because it basically has to dive all the way in there. If I had like 20 elements in there, it's going to have to dive in 20 times until it finally gets to the very last part, which is an empty list, and then pop up all the way over until it goes all the way to the top. Versus on this guy with a for loop, we know the structure of it, so we're just going to add each single part. So this is where it's like, oh, this seems kind of overkill, to be quite honest. You probably wouldn't do it this way. But it shows an example of the difference between the two. So does that make sense to people? I know it's kind of like, to be honest, if you give me one of these, like I'm with you. Like this is not super intuitive. Yeah, this is where like honestly, if you were a computer scientist, you'd spend like a couple months talking about recursion, saying, you know, different parts and what's going on. But we're going to briefly kind of going through it just to know like why it's important to XML and JSON. So, oops, I'm going to go back to here. So I'm just going to show you when I run this, it does give the same exact answer. And you can see 4,950, right? And you can see here, in this case, it actually was very, very quick. This might not always be true. So if I actually change this, this is kind of fun. If I change this to like 10,000, right? You can see, pretty fast, right? If I put 10,000 here, I think it's going to go a little slower. Oh no, it's pretty good. Let me see if I do. There we go. So I put 100,000. You can see it's kind of chugging along. It's giving me an error. Recursion error. There's too much recursion, basically. So you can see like it's going over 10,000 layers deep before it pops back out. First, if I do 10,000 up here, it might be a little slower, but it'll finally go through. You can see it's a little bit slower than the 4 milliseconds, but it's not that much slower, right? So that can give you an idea of like what that looks like. And so in reality, Python's not optimized for recursion. There are some programming languages that do that. Okay. So I'm kind of running out of time here, but I'm gonna just kind of quickly go through this parts. There's a comparison part in the learn lesson. This kind of shows you like what's going on here. And this is where like if you have this list of lists where you don't know how many lists are in here, if you try doing a for loop on this, you could try figuring it out, but if you just do a simple for loop, it's like, oh, give me the total like before, it's gonna fail. Basically, it can't add a list plus a number. That's not a thing it can do. So you have to like go deeper, and you could maybe do another if statement. It's like, oh, is there a list within a list? But then if there's a list within a list within a list, you're like, oh, then there's another part. It basically becomes this huge mess. Versus recursion can basically say, oh, I don't know what the structure is gonna be. I can go ahead and define this part in here and actually say, hey, I have this list. Basically just dive as deep as you can, and when you find that part, give me that number and just return it back. So it can technically work slower if it's just one big list, but you then pay off basically saying, well, I don't know what the structure is, and you can pay off essentially how much time it would take for you to figure it out with an unknown structure. So you can see here when I do my mice, you can see here, oh, I actually have to make sure I define this part. Oh, I didn't define L. That's why this gave an error. I'm sorry, guys. So you can see here, there. Now it fails the proper way. So now it says L, it can't do that. It can't do an L plus an L. And if I run this now, it'll actually succeed and actually add up. And this is a little printout, so don't worry about this too much. Basically, it's printing out saying how it's going deeper and deeper and deeper. And eventually it gives us the answer 45, which is what you'd expect if you added up this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So again, this is in the curriculum that kind of shows a little bit more. And last thing before I do have to head out, this depth versus breadth. This again, like if you were in computer science, we would talk this whole thing about depth versus breadth and when it's efficient and when it's not efficient. But for the most part, we're not going to worry about that because it doesn't usually come up as often. Usually, essentially, someone else has come to the package like the XML parser. We don't have to like worry about doing that ourselves. So you can see here, if I run this now, it will basically show different ways. So instead of going like really, really deep, for example, it can go far out first and then kind of combine together. So there's two ways to kind of recursively go through the function. Okay, cool. Yeah, so that kind of ends it up then. Again, the curriculum shows a lot more recursion, but I just very briefly went through parts of it. Any overall questions on these concepts?
They helped out a lot, Victor. I had a chance to look at some of the lab work, so you answered some of my questions, so thanks.
Perfect, awesome. Well, that's why I hope so. Yeah, and I think like kind of hopefully going to like a broad idea of what this is and then going to the lab kind of gives you those two kind of angles going through. All right, awesome, everyone. Well, I do have to go. I'll make sure this recording, I guess I can stop recording now, huh?